Welcome to The Connection, a series where we talk with academic and industry thought leaders about the future of networking, cloud, and security technologies. Today, we're taking it to the edge. The internet's fast, but it's not fast enough to slam on the brakes of your self-driving car to avoid hitting a deer. The internet's vast, but it can't connect to or control every remote scientific monitoring station, RFID tag, or oil rig sensor that are spread across the globe. These are just a few examples of the types of technologies and applications that need localized processing and data storage capabilities. That's what edge computing gives us, and that's what we're going to explore in this episode of The Connection. Don't forget to drop your questions in the chat where we'll answer them in real time. We have some great guests today, but before we meet them, let's learn a little bit about IoT, edge computing, and fog networks.
The world is getting smarter. Cities are becoming connected ecosystems. Businesses rely on real-time data. Homes filled with talking thermostats and robotic vacuums. The Internet of Things, or IoT, is revolutionizing the way we live and work. But with all of these connected devices comes a challenge. Sending all that data back to the cloud for processing can be slow, unreliable, and downright frustrating. That's where edge computing comes in. Imagine tiny data centers popping up close to factory floors, traffic lights, smart speakers, wherever data is generated. Edge computing processes information locally, eliminating the need to send everything back to the cloud. The result? Decisions are made faster without relying on a constant internet connection. Edge computing unlocks a whole new world of possibilities. In factories, it can help prevent equipment failures. In smart cities, it can improve traffic flow and public safety. In agriculture, edge computing can help farmers optimize irrigation and maximize crop yields. Edge devices, the network endpoints, the things in the Internet of Things often have limited processing power. Fog computing forms a bridge between edge devices and the cloud. It works as a distributed processing layer, filtering, analyzing, and pre-processing data before sending it to the cloud. That means increased processing power, saving bandwidth, and greater efficiency for the entire IoT system. Fog computing provides tremendous security benefits. It can act as a first line of defense for cyber attacks, filtering suspicious activity before it reaches the cloud. It can manage a large network of edge devices, providing updates and configurations. By storing and processing critical data locally, fog computing ensures operations continue during temporary outages, and real-time applications can trigger immediate actions. Fog computing brings cloud functionalities such as security checks, data aggregation, and basic analytics closer to the edge. This reduces latency and improves system responsiveness. Edge computing, fog computing, and the IoT are transforming our world, working seamlessly in the background and making our lives easier and more connected.
At Gartner's 2023 IT Infrastructure Operations and Cloud Strategy Conference, edge technology experts predicted that by 2025, which isn't that far away, enterprises will create and process more than 50% of their data outside of the centralized data center and cloud. And IT professionals who specialize in IoT devices and edge computing should find some great opportunities in this domain. IQ Clarity founder Ted Helmuth is our resident job expert. He's been finding innovative staffing solutions in tech for more than 20 years. Ted has his finger on the pulse of tech industry hiring trends, and his insights here on The Connection are invaluable. Ted, tell us what you're seeing in the IoT and edge computing job market.
Yeah, for the last couple of years, there's been a steady increase in demand for those types of experts that have experience in IoT, that have experience in edge computing. And if you think about it, it makes sense. You just look around and you can see all the smart home devices that we have, Ring doorbells, a smartwatch. And to power those devices, just even at a personal level, it takes extreme power from a networking standpoint. And so obviously to create the networks, to create the processing power needed to ensure those devices are working smoothly. We need engineers, we need great people who can build solutions to those problems. Yeah, we saw there's over 12,000 jobs for IoT that are currently posted, which is insane.
Wow.
And we're seeing a ton of jobs for software engineering, embedded engineering. Those jobs tend to, be on the bachelor's for computer science, or at least have, an education focused on engineering.
Right.
We're seeing on the edge compute side of things, tons of network engineering opportunities. And so, yeah, absolutely need as much education and training as possible and experience.
Right. So you're seeing these positions kind of posted as IoT or edge, or are they really kind of those skills? Are those skills embedded in networking and cloud or computer science or software job postings?
We do see job titles that say IoT software engineer, IoT firmware engineer, to really show that they're looking for focused expertise in that vertical.
Mm-hmm.
On the edge computing side of things, I've seen a few roles where they specifically call out edge computing in the job title, but a lot of times it's just sort of embedded in a network engineering job description.
So Ted, what does a strong candidate look like in IoT or edge computing?
Generally on the IoT side of things, we're seeing a lot of candidates that have a background in software engineering, that have expertise within embedded and firmware. So the more that you can cover the full stack, which is everything from that microchip all the way up to whatever user interface the user is using to power that device, the more opportunities will be out there for IoT. For edge, we're seeing a little bit of everything. So, obviously network engineering skills are critical. Experience with some of the networking protocols that are out there. Wireless, of course, is important. Security has become a very big concern for all of these, because every additional node you put on the network is another potential loophole where a hacker could get in and exploit your data or your information.
So what about like AI, 5G? You mentioned cybersecurity. How are those three things affecting or influencing demand for talent in this space?
So AI, wow. I mean, that has taken over my LinkedIn feed lately. So you can't, scroll 3 articles without having something about
Right.
AI.
Yeah.
Something needs to power that intelligence. And again, when you look at edge computing, when you can get that processing power as close to the device as possible, the latency goes away, the security gets a little easier to maintain, and just the power that you can harness right there at the device level is unbelievable.
Right.
So with AI, it's just very much powering the devices. Look at NVIDIA, one of the largest producers of edge compute technology, and just look at their stock price over the last, maybe not lately, but over the last 2 years.
I missed the boat there.
So if you think about 5G and the direction that's going, it's powering everything right now. If you look at my home internet, I'm talking to you on a 5G network right now. If you think about self-driving cars, think about the direction that the world's going with all these smart devices and all this technology. 5G is just the beginning, but it has a profound impact on edge computing, IoT, and really all the new products that are coming out. So absolutely, 5G is a major factor in the advancement of edge computing, and will continue to drive innovation.
Yeah.
We're opening up a lot more opportunity for malicious actors to penetrate networks. When you have more nodes, there's more potential, and some of those nodes aren't as secure as they should be. So security becomes very important when you look at what products you're allowing into your home network, into your business network.
We talked earlier in the episode about 27 to 29 billion IoT devices. That's a big number, and you're right. That's a lot of points of failure and a lot of access points.
Absolutely.
Yeah.
It's exciting and scary at the same time.
Hey, Ted, this is fantastic advice and fantastic insight. Thanks for being here with us to talk about the job market in IoT and Edge. And we absolutely look forward to picking your brain in a future episode of The Connection.
Wonderful. Thank you for having me.
In a world with billions of users on the internet and many times more things on the internet, it's very important for us to understand the difference between the technologies that support traditional networks, cloud computing, and then IoT devices, the fog network, and edge computing. So today we have a panel here with us to discuss exactly that, and I'm really interested and excited to jump into that. With us today is Scott Allen, who has over 30 years of tech experience that includes developing products specifically for industrial automation and industrial IoT. He's worked in global deployments in energy, utilities, environmental monitoring, and unmanned systems markets. Scott, thanks for being here today.
Thank you. It's my pleasure.
And with us also is Lori Davis. Lori's an instructor on our networking team here at WGU, and she's been with us for over 5 years. Prior to joining WGU, Lori worked in managed services supporting large educational infrastructures. Lori, thanks for being here today.
Thank you. I'm glad to be here.
So Scott, I'm going to start with you. In 2018, in a NIST special publication, Dr. Michaela Yorga and her team created a conceptual model of fog computing. In that publication, the authors indicated that, at least as of 2018, no consensus existed on the distinction between the concepts of edge, IoT fog, and mist computing. So they created one. So I ask you, has that model taken root broadly, or are we still sort of in a state of confusion with these terms and concepts?
I think that it has taken root in many respects. When you think about what happens after you leave the cloud and you get out into an enterprise or industrial environment, and you start to look at things like fog computing, where you have layers of compute that do different kinds of computation, and then the further out towards the edge and to the actual IoT devices, those computations get more specific and more detailed and smaller in nature. That certainly has taken hold throughout certainly the industrial world. The further you get out into those environments that can be very remote and very limited in power and in resources like bandwidth, the computations do get smaller and more specific, which would kind of lead you from the cloud to the fog to the very edge of that, to the mist, and then where you actually have your edge devices, the sensors that actually do things for that environment.
So tell us a little bit more. How do you define mist computing?
Like I said, mist computing is kind of a computation layer, a compute layer that is very close to where the sensors actually work. And the kinds of computations they do are generally pretty simple. I can give you one example. For example, if you're in an oil and gas environment and it's in the middle of North Dakota, generally you have very limited bandwidth. But you still need to get information. One way that mist computing works in that environment is you may have an edge computer device that actually pulls in information from the pump. And the compute in that environment, the computer would have an actual table of what normal is. In other words, what's my typical range of temperature or pressure, et cetera. And then it pulls the information from the sensor and compares it in that table. Are we normal or are we not?
Right.
And if we're not normal, if we've exceeded some sort of threshold, then that's the data that gets moved back to the fog.
Okay.
If it doesn't, if it's still static and it hasn't changed as within normal variances, then that data stays there. It doesn't actually migrate. So
Right.
you save bandwidth in very limited bandwidth or situations. Does that make sense?
Yeah, it does. And it sounds like in application, these concepts are very well defined. It's maybe just in the general vernacular that a lot of people haven't extended it out to the edge or to the IoT devices and understanding the technologies and the infrastructure that makes that work. So Lori, Scott just talked about latency, and I really think that's one of the main drivers in these paradigms. Talk to us about that just a little bit. Why is it important that we do compute at the edge instead of just sending everything back down to the cloud and having it done there?
Right, and you're right, the cloud is very powerful, but if everything is done in the cloud, then that means that the latency kind of exacerbates, especially like Scott was talking about. The more sensors and the more nodes you add in, then the more latency there's going to be. So if you can move some of the processing, or at least the majority of the processing, to the edge or to the fog, then the latency from the cloud becomes a lot less.
So it sort of comes down to function, right? If that the device has to make decisions or react or shut off controls or put on the brakes of an EV, all that has to happen
In
at
real
the
time.
device, and it takes too long for that decision to be processed remotely.
I agree, yes. You definitely want real-time processing.
So you work with our networking team. How do you explain the difference between edge devices and what we would consider to be a traditional router or switch?
Okay, well, traditional routers and switches work at the core of a network, and their main function is to forward traffic. They do very little processing, whereas edge devices by design do a lot of the processing, and they also forward traffic. So they are, I won't say more intelligent, but their intelligence or their programming is different.
And are there fog-specific devices as well? We hear about edge devices all the time, but are there fog-specific devices?
Yes, I mean, it's more or less a paradigm or an architecture, but yes, there are actual fog devices, including things like smart cameras, sensors and actuators, and so on.
How do you see the combination of edge, fog, and cloud computing coming together to enhance the cybersecurity functions?
It has to do with latency. So if everything has to go to the cloud to be processed, things are not happening in real time, which means that's an edge or a way for an attacker to get into your network. So if you actually do some of the computing at the edge, that's still within your network, so it's within your control, it's within your security realm. And same thing with fog. Fog is very much near the edge too, so if you put some of the compute on that, then the cloud has to do a lot less computing. Plus, all three of these layers have their own security built in.
So it's interesting because my thought first goes to, oh, hey, the data is not centralized. But you're saying it's not even where the data is as much as it is the latency that it provides opportunity to be exploited.
Exactly.
That the edge computing helps protect us against. Hey, Scott, in your experience, what role does security play in IoT edge and fog computing?
So security is a massive both concern and focus for any implementation of certainly an industrial setting, especially because a lot of it is outdoors. It is very remote. It is accessible physically in many cases. But there are a lot of ways that you can that organizations do a lot of things they implement to shore up their security potential for breaches. For example, they have physical security at the site. They put fences. They put, they gate it. They put their equipment that is part of the mist or the cloud or the fog in shacks and protect that physically. The equipment that they put inside those shacks is often, it certainly has it's been altered physically to remove certain ports from being accessed physically. There is also hardened OSs that they have subscribed to. And then many of the technologies they deploy in those areas, for example, a lot of them use what they call frequency hopping to move information from one location to another. So they encrypt the traffic, plus it's frequency hopping. So across a radio network, it's very difficult to identify what the frequency hopping pattern is, plus decrypt the traffic when it's in flight. So there's a lot of things that they do just at the edge level that protect them for the most part. Back in my McAfee days, we had a saying, hard and crunchy on the outside and hard and crunchy on the inside too. What these implementations are, they try to make it hard and crunchy on the inside without impacting the flow of information in these networks.
What role does blockchain have in the edge and fog and IoT space?
So it has a significant role already in that distributed computing models with distributed compute and storage is already fairly well defined in some of these networks, where you've got applications that are spread across multiple edge devices that have compute power and have disk storage space. So the concept is already there, and I think it's just going to grow exponentially as the intelligence within the fog and the mist continues to expand. The number of applications we're running today in those environments pales in comparison to what it will be in a year, in 5 years, and in 10 years. So, that kind of, that blockchain type of technology will be critical to make sure we have sufficient CPU and memory and also storage space to have those apps where they need to be. And in the event that one of the devices goes down or is no longer available, the resiliency that blockchain technology brings in is super important.
Right.
Especially like Lori said, when the actual command and control needs to remain out at that edge. So if something in that mesh goes down, something needs to take its
The
place
rest of the
quickly.
network
Yeah,
just stands that up.
correct.
Well, what do you see as the most significant challenge facing the adoption and implementation of edge and fog computing in enterprise environments?
Most significant challenge in enterprise environments, I think, is understanding the power of what it can actually do in a particular environment. When I think of enterprise, often I think of more of an in-house type of environment where you may not think about things like securing these devices or what the applications are. That's probably some of the larger concerns. When it goes to the industrial side or more remote sites, I think physical access is one of the things that people are concerned about. How do I, for example, navigate a mountainside where there may be wildfires and I want to make sure that I'm monitoring that environment for those wildfires?
Right.
What does that look like? And so there's still a lot of questions that need to be answered for those types of implementations.
I mean, it's easy to lock down a data center. It's easy to lock down your business, but to have to protect a weather station or a...
Not so easy.
Not so easy. Yeah, I'm glad you mentioned that. Thank you. Hey, so Lori, let me ask you to kind of build onto that. So what emerging trends or technologies in the field of IoT and edge do you find particularly exciting and particularly promising?
I would say it would be more about the security of these up-and-coming edge and IoT devices. Right now, a lot of our IoT or smart devices are not really all that smart. They are usually, not always, but usually low-powered and cannot handle today's encryption standards. So these up-and-coming edge and compute devices can handle our more modern encryption standards and will make everything a little more secure.
So what's exciting to you is the increasing power and the increasing utility of these devices. That's interesting. So Scott, what's one key technology or trend that we ought to be watching in IoT?
So I would say that maturity itself is what I'm watching for. Maturity in the entire landscape, and then the types of applications and the types of deployments that you see. I mentioned a moment ago about the wildfire thing, right?
Yeah.
That is actually something that is really meaningful in that if this environment matures to the point where we can have true visibility into where these wildfires can occur and detect those wildfires, detect where they're moving from, where they started, and where they're going to, then we can react more appropriately. And the reaction itself can actually be part of that IoT infrastructure as well. With the emergence of new swarming technologies with drones, and some of the way they interact with the Internet of Things and with the fog and the cloud computing, there's a lot of things that we can do in those types of environments that would save lives and really reduce the risk of damaged property and all the things that are terrible with wildfires, as an example.
Well, let's build on that. What about AI then? I mean,
AI certainly has a part in that as well.
Yeah, and how do you expect to see that continue to mature in the space?
Well, I think AI inside of fog computing is going to be a real learning experience for everybody, right? When we start to learn, and those machines actually start to learn from each other what's actually happening, and they start to bring in other information, like, for example, Google Maps and weather maps and things of that nature. And I've kind of seen some of the early instances of this in the oil and gas industry, where they're watching for weather patterns that move through certain oil fields, and they want to make sure that the pumps are in a certain state for that. Now, that's not AI per se, but as AI continues to emerge, that could easily reside in those clouds, and it could be very automated to change the nature of what the pumps are doing in those remote areas when certain weather events happen or certain physical events happen.
You feel the same way, Lori? What do you think about when you think about AI and IoT and edge computing?
I think that we're still in the infancy of it, and where it's going to go, we're not really 100% sure yet. But I think the ability to be able to monitor current conditions, like even wind direction, you were talking about, wildfires, knowing how the winds are going to shift, that will help us, further, help these systems to learn and mature.
Man, you guys are talking about wildfires and industrial. So I thought we were going to talk about like electric vehicles in my Fitbit while we were here. Well, this has really been enlightening for me, and I'm sure for our audience as well. But before we wrap up this discussion, let's do a speed round. So I'm going to start with you, Lori. What's the biggest misconception about fog and edge computing?
I think the biggest misconception is that fog and edge computing is going to replace cloud. In fact, it's really going to enhance cloud. It's going to make everything function a little bit more smoothly and a lot more seamlessly.
What about you, Scott?
I would agree with that, and I would add that people think that the fog and edge computing can be less secure, and I don't think that's necessarily true either.
What's your favorite use case for edge computing that you've ever encountered?
One of the deployments that we had, that's a fun one, was in China. Mm-hmm. There is a city in China that is using IoT and a smart city kind of deployment mm-hmm. of fog and edge computing to look at the flow of tourists that are moving through the city during the tourist season. And they alert the tourists on their phones as to what events or what places they might want to go based on what the traffic flow is in those environments.
Wow. Okay.
Which is really, really kind of a cool next step for smart cities. When you get there, you download an app, and as you're going through the day and you're visiting these sites in the city in China, they will make recommendations based on the traffic. There's a lot of people over at this place, but there's not so many over here. Wow. So you might want to go and see this before you go see that. It's really kind of cool.
That sounds very cool.
That was really way nice.
What about you, Lori? What do you think? What's a really fun or favorite implementation?
I'm going to kind of tag on with Scott here. I think autonomous vehicles. Okay. The ability for vehicles to communicate with each other and with the traffic grid will, I won't say will get rid of rush hour necessarily, but it will make rush hour a little more seamless. It will make you not dread it as much because all these devices being able to communicate with each other will help you to avoid the worst of it.
Last question, sticking with you, Lori. What's your favorite IoT device?
I'm going to go with robot vacuums. Our current crop of robot vacuums right now are the kind that just go forward until they bump into something and then they change directions. For a robot to be able to actually efficiently map a room before it vacuums will not only make that more efficient, but it will also use less power.
So now we're talking my language. We're off of the wildfires. We're talking into somebody doing my household chores for me. Thank you. Scott, favorite IoT device?
The one I like right now is my cameras. I can isolate my cameras to look at just people and animals, and so it's really interesting to see the different birds. A big hawk came and landed on the deck the other day, and so you can set those devices to really be smart about what they're actually looking at and recording.
Well, this has been really fascinating. With billions of users on the internet and many times that number of things, it's really important for us to understand the complexity of the networks and the technologies that make those things work. And whether we're talking about a smart robot in our house or we're talking about a camera that can help us identify what our pictures, or whether we are talking about industrial applications, it's super important for us to understand that technology, understand the maturity and the complexity of that technology, and also to understand how to secure it, because all of those things are different disciplines, or at least build on the disciplines of traditional networking and what I think today we could call traditional cloud computing. So I want to thank you, Lori, and thank you, Scott, for joining us on this episode of The Connection. This has been a fantastic panel. I appreciate both of you coming in and talking to us and sharing your expertise.
Thank you.
Thank you.
We've covered a lot of ground in this episode, and now we can step back from the edge and take in the big picture. Smart devices like Fitbits and iPhones, watches, cars, Ring cameras, they all shape the way we live. And IoT controls in manufacturing plants, our global supply chain, and thousands of other applications drive the way we do business. Building these devices, the systems and the networks that they operate on, and keeping them and the data that they generate secure is a Herculean task that can lead to a very rewarding career. At Western Governors School of Technology, we aim to stay on the leading edge of these innovations and to fulfill our promise of creating opportunity through education. Thanks for joining. I'm Dave Huff, signing off from the WGU studios. See you soon on our next episode of The Connection.